You already saw this simulation when we were talking about electrolytes, and you may already remember that when you put a salt in water, and if it's a soluble salt, it will go in as a solid crystal like that, but as it hits the water, it will dissolve and break into its positives and its negatives parts. In this simulation, the Na pluses are represented with the pink ions, the little tiny pink spheres, and then the Cl minuses are the green spheres. And so a soluble salt, when it dissolves in water, it isn't going to have hardly anything at the bottom. Like you can put a whole lot in of a soluble salt and you won't have anything sitting at the bottom. We will be dealing with insoluble salts coming up, but not in this module and how they interact with water. But for now, we're just looking at these soluble salts, and we're going to assume we're going to give you concentrations where everything dissolves, there's nothing left at the bottom. And again, you can put a lot of a soluble salt in water and it dissolves. You've also seen that when you put salt in and you hook up a battery system, you're going to have a good flow because it completes the circuit. You've got the positive and negative ions in the water. So the thing that soluble salts can do, and I don't have an exact simulation that does this perfectly, but I'm going to be explaining it in a future video where you can see the reaction. But sodium and chloride doesn't do this. Sodium, no part of sodium is attracted to either part of water. It is not attracted, it will not bind to the water, it just floats around as Na+. And there's no part of the chlorine that's attracted to the water either, and it won't grab onto any of the water and make any kind of a pH. But there are some salts that will do something like this, where if you look at the HA, and if you assume that's more something like, I don't know, maybe an Mg or something, just pretend it's some kind of a salt. What some salts can do is they can have one part that is attracted to the water, and what that one part will do is instead of hanging out by itself as like just a circle of red on the right hand side, it will interact with the water and it will grab some of the water and it'll end up kind of breaking apart a little bit of the water and causing a pH to happen. So that's what happens with some soluble salts. So in this section, you're going to learn how to tell if it's going to be a neutral soluble salt, like the sodium chloride, where neither part will interact with the water, or if it's going to be a salt that will create a pH because one of the two parts of the salt is interested in either the OH group or the H group of the water, and it will split apart a portion of the waters, and it will cause a pH.